In today's video, we're going to be going over Chapter 13, which is called A History of Calculus, but it really deals more with ratios and proportions, which is all about fractions. The first thing we need to talk about is the definition of a ratio. A ratio is a comparison of two quantities and is usually expressed as a fraction. In fact, a fraction can also be called a rational number, because one meaning of the word rational is having to do with ratios, and we know that ratios are the same thing as fractions. So if you ever hear in another math class where they say something is a rational number, then you want to think of a fraction when you hear that. Let's look at an example involving ratios. A college may have a ratio of 2 men to 3 women. So one way to express that is 2 men divided by 3 women. Now here's our question. It says, if 3,000 women are enrolled at the school, how many men should there be? So here's how I set up this problem. I said, okay, well, I know that there's 2 men for every 3 women. So that's the same thing as question mark men, we don't know how many, divided by 3,000 women. So compare your denominators. We're going to say, okay, well, to get from 3 to 3,000, I need to multiply by 1,000. So I need to do the same thing to the numerator. So I'm going to take my 2 and I'm going to multiply it by 1,000 to get 2,000 men. All right, so there's our answer. If there are 3,000 women enrolled at the school, we expect there to be about 2,000 men. This equation is an example of a proportion, which is where you have 2 fractions set equal to each other. So you have a fraction, an equal sign, and another fraction. Here's another definition. We use this definition all the time. We may just not know the formal definition of it. So it says, a rate is a ratio that is used as a form of measurement. A rate is going to involve 2 separate units of measure. So for example, if someone drives 45 miles in 1 hour, what is the ratio of distance to time? So that's a rate because you're using the unit of distance and the unit of time. All right, so let's answer our question. If someone drives 45 miles in 1 hour, what is the ratio of distance to time? All right, so the ratio of distance to time, that's going to be the fraction, because we know ratios are fraction. So distance divided by time is 45 miles divided by 1 hour. This is the driver's average speed, or you could also call it their average rate. Now let's look at another example with rates. It says, if a $2,000 deposit earns $100 interest in 1 year, what is the ratio of interest to principal? So again, there's your 2 units, interest and principal. Okay, so principal is the amount that you originally deposit. So this is always going to be the bigger number. All right, so our ratio of interest to principal, that's going to be interest divided by principal. They told us that our deposit earned $100 interest, and that our principal was $2,000. So I'm going to divide this. I'm just going to lose my dollar signs just so I can plug this in the calculator. Now, if I plug that in the calculator, that gives me 0.05. Now, this is called the interest rate. So you may have heard that word before. If you've ever taken out a car loan or a mortgage on a house or any type of loan, you've heard of interest rates. Now let's use what we learned about ratios and proportions to complete an example. A car's odometer read 57,362.5 at 2 p.m. and 57,483.8 at 4 p.m. So they drove a little bit in between those 2 hours. The first question asks us to find the car's average rate. Okay, so the 2 units that we have here are distance and time. All right, so we're going to do distance divided by time. We know that's what the average rate is. Right, so we're going to look at how many miles they traveled divided by how many hours they spent traveling. All right, so let's do some calculations. Let's figure out how far the car traveled. To figure this out, we're just going to take our odometer readings and we're going to subtract them. All right, so it says the car's odometer started at 57,362.5 and ended at 57,483.8. So you're going to take the bigger number and subtract the smaller number. All right, so bigger number minus smaller number gives you 121.3 miles. Go ahead and pause the video and you can check this on your own calculator. Now we know how many miles that were traveled. So let's plug that in for miles. We don't know how many hours yet, so let's figure that out. Let's figure out how long the car traveled for. The car started traveling at 2 p.m. and ended at 4 p.m., so the car traveled for 2 hours. So let's plug in 2 for our hours. Now all we need to do is go ahead and plug this in our calculator. 121.3 divided by 2 is 60.65 miles per hour. So that's the car's average rate. So that's on average how fast they were traveling between 2 and 4 p.m. In part B, they're asking us to find the distance that would be traveled in 3 more hours if they continued traveling that same average rate. So if the car is traveling 60.65 miles per hour, that's what we found in part A, then we should multiply by 3 to figure out how far they'd travel in 3 more hours. So we do 60.65 times 3. Go ahead and pause the video now and you can plug this in your calculator. So doing that multiplication gives us 181.95 miles. So that's how far they would travel in 3 more hours. So almost 182 miles. Now I'm going to present this definition. We won't use it that much in this chapter, but it will come back up later, so I just wanted to make sure that you had seen it before. So delta notation is used in calculus, and so that kind of helped. That's one reason I wanted to mention this, is because that ties it to why we mentioned the history of calculus as the title of the chapter. Delta notation is used to describe changes in quantities. It consists of the symbol delta, which looks like a triangle, which means change in, followed by the letter that refers to the quantity that changes. So for example, if we let t be time, then delta t would represent the change in time. Now let's move on to another example using ratios and proportions. It says, a carat is a unit for measuring the fineness of gold. Pure gold is 24 carats fine. Gold that is less than 24 carats is called an alloy rather than pure gold because it includes some other type of metal. The number of carats is the numerator of a ratio between the amount of pure gold and the total amount of material. The denominator is always 24 because that's the total amount of pure gold. So if your ring is pure gold, then it's 24 carats. If you have something like in the next example, it says if a ring is 18 karat gold, find what portion of the ring is pure gold. So we're going to set it up exactly how that problem told us to. It told us that the number of carats is the numerator, and 24 should always be the denominator. So we have the amount of pure gold divided by 24 carats. Our ring was 18 carats, so that goes in our numerator. If you have a problem like this on the homework, you may have something like 12 karat gold or 16 karat gold. But our ring is 18 karat gold in this example. All right, so here this is going to tell us what portion of the ring is pure gold. So I'm just going to lose the carats just so I can easily plug this in my calculator. So go ahead, pause the video and plug this into your calculator. I'm going to make this into a simplified fraction, but it would be fine if you wrote this as a decimal as well. I'm going to reduce this fraction, and the way that I'm going to do that is I'm going to look at both numbers, the one in the numerator and the denominator, and I'm going to see what factor they have in common. So what number goes into both of those evenly? The highest number that goes into both of those evenly. 6 goes into both of these, so I'm going to divide the top and the bottom by 6. So dividing the top and the bottom by 6, 18 divided by 6 gives me 3. 24 divided by 6 gives me 4. So this tells me that 3/4 of the ring is pure gold. Now this is the same problem, it's just part B. And this one says, if the ring weighs 7 grams, so that's the total weight of the ring. If the ring weighs 7 grams, find the amount of pure gold in the ring. Okay. So we're going to find out how many grams of pure gold are in this ring. All right, so here's how we're going to set this equation up. We're going to say we're going to take the amount of pure gold divided by 24 carats. That's what we did in part A. We're going to set that equal to the weight of pure gold divided by the total weight of the ring. So this is like part divided by whole. All right, so using what we found out in part A, we have 3/4, remember that was from part A, equals X grams, that's the weight of pure gold, that's what we're trying to find out, we don't know that, so I'm just calling that X, divided by the total weight of the ring, which they told us was 7 grams. Alright, so I'm going to now cross multiply to figure out what X is. So I'm going to go ahead and just get rid of the grams, just to make this a little easier, a little smaller. And now I'm going to cross multiply. So if you've never cross multiplied before, I'm going to show you how to do that. But if you have cross multiplied before, you remember how to do this, you can just go ahead and work on your own. Alright, so I'm going to start by multiplying 7 times 3. So notice I'm going across, that's why it's called cross multiply. So 7 times 3 is 21. Right, now I'm going to go the other way across. 4 times x is 4x. So we have 21 equals 4x. Notice that the equal stays in the same spot. So the equal sign does not move. All right, now we just have to solve for x. We've gotten rid of all of our fractions, which is nice. So to solve for x, we're just going to get rid of that 4. So we need to divide both sides by 4. That's going to cancel out the 4 on the right. And we can plug in the left-hand side into our calculator. So 21 divided by 4 is 5.25. Now don't forget the units here. This was 5.25 grams. So that's the amount of pure gold that's in the ring. So out of that 7 grams, 5.25 is pure gold. 5.25 grams is pure gold. Now, the next thing we need to talk about that has to do with ratios and proportions is similar triangles. If you take a triangle and you magnify it, so just imagine like you're kind of zooming in or stretching it out, the sides will enlarge, but the angles of that triangle do not enlarge. These triangles are called similar triangles because they have the same exact angles. Similar triangles will have the same shape and the same angles, but the sides will have different sizes as shown below. So you can see here we have 2 triangles that have the exact same angle and side, so 47 degrees, but the sides have different lengths. Here's the theorem or definition or formula, whatever you want to call it, for similar triangles. It says if 2 triangles are similar, then the ratio of their corresponding sides are always equal. So we have A over C, those are the matching left-hand side of the triangle, is equal to B over D, which is the matching bottoms of the triangle. You don't necessarily need to have this formula memorized, but you should know how to use it. We're going to do another example here, and we're going to use what we know about similar triangles to figure out what B and C are. So we have this small triangle, 3, 4, 5, and then we have this big triangle, 12BC. The way that I like to set these up is I like to do little triangle divided by big triangle. So the side of the little triangle divided by the side of the big triangle. And you're always going to start with the sides that you know on both triangles. So notice that we know the right-hand side of both triangles. On the little triangle, it's 3. On the big triangle, it's 12. I'm going to find B first. You can find C first. It's totally up to you. So I'm going to take little triangle divided by big triangle. So 4 over B, that's the bottoms. So little triangle, the bottom of the little triangle is 4. The bottom of the big triangle is B. And set that equal to the right-hand side of the little triangle divided by the right-hand side of the big triangle. Take a minute and pause the video. Just make sure you know how to set this up. And then we'll cross multiply to figure out what B is. Now let's cross multiply. So I'm going to take 12 times 4 is 48. And then I'm going to go the other way. B times 3 is 3B. I like to put the number in front, but you could do B times 3. It's the same thing. Now I'm going to get B by itself, so I need to divide both sides by 3. On the right-hand side, the 3's are going to cancel out. And on the left-hand side, 48 divided by 3 is 16. So there's the bottom of our big triangle. The bottom is 16. Now, something that you should know about triangles is that the longest side is always going to be C. So if you look at that big triangle, C should always be the longest side. That's called the hypotenuse. All right, so let's look at how we find C. We're going to set this up the exact same way. In fact, the right-hand side of the proportion is going to stay exactly the same. So we're going to do, again, little triangle divided by big triangle. So we have 5 over C. That's sort of the top of each triangle. So the top of the little triangle is 5. The top of the big triangle is C. Set that equal to the right-hand side of both triangles. Now we're going to cross multiply. 12 times 5 is 60. C times 3 is 3C. So divide both sides by 3. 3's cancel out on the right-hand side. And you're left with C equals 20. And that's it. You should have some problems exactly like this in the homework. If you need any more extra examples, make sure you look in your textbook. Chapter 13 is only available on your ebook that's on WebAssign. So if you need to find some extra examples, just look on your ebook on WebAssign.